So we move to the new chapter now, which is chapter 6. Now, the difference between chapter 6 and also the previous chapter is that in chapter 6, we are moving to the supply side of macroeconomics. So recall back the thing that we have learned previously from chapter 1 until chapter 5 is about aggregate expenditure, and then we have ISLM. All of these shows how each component of expenditure, especially this, I'm talking about this. We have consumption, we have investment, we have government spending, and then because we don't open the economy to international trade, so that's why we have not discussed the export minus import or net export. But all of these are basically on the demand side. Why do we call it on the demand side? Because all of these are the expenditures of economic people in the economy or in a country. But in order to meet the demand, then we need to produce output. To produce output, we are talking about the production side. And in the production side, if we need to produce output, we need to have input, or what we call factors of production. Now, there are 4 different types of factor of production. If you can recall back the study in the undergraduate level, number 1 is entrepreneur, number 2 is labor, number 3 is capital, and the last one is land. Okay, so for our purpose of study here on the supply side, we are focusing on labor and capital. Okay, so here, when we talk about labor and capital here, this labor and capital will be used by the entrepreneur to produce output. When we talk about output, it is similar to product, also similar to goods and services. So those are the same term, yeah? This. Right. So here, things labor and capital, and labor is denoted as L at macro level, and sorry, not L, N, because usually L is in micro study N, and capital is K. Okay, so producer combines both labor and capital to produce output. We must understand that there are short run and also long run production. In the short run, only labor can vary but not capital. So capital is constant. That's why you can see bar here. It means constant. But in the long run, both capital and labor can change. Okay. So if we talk about production function first, then we go into detail about demand and supply in the labor market. Okay. So this is what I said just now. So we have N here as labor, K here as capital. So like I said, we have short run and also long run periods. In the short run, only labor input varies, and in terms of model, it is written as this here in equation 1 here. Output, this is a real output. It's a function of labor and also fixed capital. So if you see this, that means the output here is in the short run. Okay, now let's look at it in the form of graph. In the form of graph, in the short run, remember this is we are talking about the short run. So here, let's say we have real output on the vertical axis, and then number of labor is here. And in the second graph here, we have marginal product of labor, and here is the number of labor. So in the form of graph, in the first graph here, I draw this. Okay. Now this is production function. Recall back the equation written for production function is equation 1 or expression 1. This is production function graph, and here we want to relate it with marginal product of labor. Now recall back in your undergraduate study, marginal product of labor is actually the additional product or the additional output that you produce after adding one additional unit of labor. And in your undergraduate study, when you talk about marginal product of labor, you wrote it this way. But here, because we are talking about macro, usually we use N. It doesn't matter actually, but here we just standardize it based on the textbook. Okay, now, so MPN is actually the change in output over change in labor, isn't it? So this is what you saw in your undergraduate level. Now, so the change in output is basically, if I draw it here, you can see this one is actually the change in output. This one is actually the change in labor. Let's say from N1 to N2, and then here Y1 to Y2. So it means Y2 minus Y1 over N2 minus N1. That's what you learn in the undergraduate level. Okay, now let me erase this one because I don't want to mess the graph. So it's actually more or less the same thing, but this time we want to use a generic function or mathematical function rather than doing it one by one like undergraduate level. Yeah. So I clean up this mess first, then I'll show you how does it look like. So mathematically speaking, if you look at the drawing here, the drawing of curve, you can see that we can divide the curve or total product curve here, total production, into three different segments. Okay, so here I call it, let's say N1, here N0. From 0 to N1, you can see it is upsloping, but the shape looks like this. You get what I mean? From N1 to N0, it is upsloping also, but the shape looks like this. And beyond N0, it is decreasing. So both of these is upsloping curve, but what makes them different? If you can recall back, this one is what we call convex, and this one is what we call concave, isn't it? Okay, so go back to your basic maths in undergraduate level, yeah? And then this one is downsloping. Both of them upsloping here. Okay, that means although they are upsloping, but the rate or the slope of total product is not the same. Okay, so the slope of total product or production function, yeah, in this case production function, basically looks like this. You look at the way I draw it, right? So here, oops, it's wrong. Let me fix this bit. Okay, right. So here it looks like this. Okay, so this is N1, this is N0. Alright, now what you can see here is that although the slope in the first segment is upsloping, in the second segment also upsloping, this is the third segment, but you know that in the first segment it is convex. Okay, so when it is convex, the slope increase at increasing rate. How do I know? The slope of production function is actually MPN. Can you see? Okay, it's actually MPN, and you can see here the slope is upsloping. How do you know? Because it is increasing, but the way it increases is increase at increasing rate. How do you know? Because MPN, marginal product from one labor to another, new additional labor becomes more and more. How do you know it becomes more and more? Because marginal product or the slope here is increasing. Okay, but after N1, then you can see the convexity changes to concavity in the second segment. This is concavity of the curve. Yeah, when it is concave, it is increasing. because the slope is still upsloping, it is increasing, but at decreasing rate. How do you know? Because the slope value decreases from one labor to another additional labor, up to the point when it reaches n naught labor, where we have maximum total product. At maximum total product, or sorry, maximum production function, the slope is flat. When the slope is flat, the slope is 0. Because MPN is the slope, MPN is 0. That's why you can see here 0. After that, it decreases downsloping and the slope becomes negative. If it is downsloping, of course, mathematically, slope is negative. Alright, so in the first segment, okay, MPN is positive, but at increasing rate. In the second segment, MPN is also positive, but at decreasing rate. Okay. Okay. When total product, production function, I always remember total product. When production function maximum, MPN equals to 0 because MPN itself is the slope. The slope is flat. When number 4, MPN or the slope is negative, production function decreases. You can see production function decreases, down sloping. This is the basic that you have learned previously. And in the second segment, remember this is a short run, yeah, because you know that capital is fixed here. In the short run here, if we talk about the second segment, there is a kind of law that you have learned in the undergraduate level, that is law of diminishing return. Let me erase the mess here first. Now, when we talk about the law of diminishing return states what? This is just revision, yeah? As you increase the number of variable input, in this case, variable input is labor, total product still increase, but at what rate? At decreasing rate. Okay, so we're talking about this. So this is basically law of diminishing return. Why law of diminishing return occurs in the short run? Because you have to remember the amount of capital machines and also building are fixed. So when you want to produce more, the only way to produce more is to increase labor, to increase the variable input. But then the more you increase the labor in the production process, it becomes crowded. So the additional products here becomes lesser and lesser. You can produce more, but not as higher as before in terms of additional output, because things is becoming crowded, becomes less efficient. You get what I mean here? The only way is to expand the building, to buy more. You have to buy more machines so that those additional labor can use machine. Because sometimes when you hire more labor, when you already have 2 machines, when you hire 10 laborers and each machine only requires, let's say, 3 people to use, so what happens to the 4? You get what I mean here? Alright, so that's the idea of law of diminishing return. Alright, so from there you should know what? You should know how to explain the relationship between total output, okay, which is production function, with marginal product, in this case marginal product of labor, and also average product in the short run. If you can recall back, okay, so we have marginal product of labor, we have average product. So marginal product looks like this, and average product looks like this. Also, you can basically divide this into 2 segments. Look at the intersection between average product and marginal product. First segment and second segment. This is revision of your undergraduate. Yeah, I won't explain more than this. What I've explained in the video here is for your revision, but the additional bit of your revision must be done by yourself, because otherwise I cannot finish my syllabus here. I have to explain other things which are more important. But if you don't get this correctly, then it will be a trouble for you to understand higher level, which is master level. Okay, so here, as you can see, marginal product and also average product, you imagine this one is GPA every semester, and then this one is CGPA for the whole of your study. So usually for this semester, if you work so hard, your marginal product or your GPA will increase, let's say from 3.4 to 3.9. And let's say initially your CGPA is 3.4. So when your marginal product or GPA increases to 3.9, this semester your CGPA also increases, let's say from 3.4 to 3.6, for instance. So that's what happens in the first segment here, in which as long as your, again, yeah, as long as your marginal product, as you can see here, is higher than your CGPA here, you can see in the first segment, the curve here, let me erase the circle, the curve here, this is marginal product, above the average product, isn't it, above, you can see 3.9, 3.4, then your average product, which is CGPA, will increase. And the contrast is in second segment. In relation to that, let's say here is N naught. Yeah? So you have something like this. This is marginal cost, and this is average cost. This is revision, yeah? First segment, second segment. So it's just a mirror reflection. So please do revision on this. Yeah? Alright. Now we are done with production function. Now we want to go back to our main objective, that is to talk about the input that we need to have so that we can produce output. That input is labor. So when we talk about labor, we need to know the market of labor, because we want to know the price of labor, and the price of labor determination in the market needs demand and supply. Okay, if we have market for apple, then we have price for apple and also quantity for apples, isn't it? So for labor, we talk about the price of labor refers to wage rate, and we talk about the quantity of labor, we refers to labor hours. So when we have N here, whenever we have N here, then we refer to labor hours, not labor in terms of one labor, two labors in terms of people, but in terms of hours. Yeah, we know that market, okay, demand and supply. So we have price here, we have quantity. So like I said, for labor, the price here is wage rate, and then the quantity here is N. All right. Now, for us to determine what is the equilibrium wage rate, what is the equilibrium labor hours here, we need to study demand and supply separately first. After that, we combine both of them to get labor market. So let's look at the first, part of labor market, which is demand. So here we are, demand for labor. So in order to study the demand, aggregate demand for labor at the macro level, we need to study the individual firms' demand for labor first. So demand for labor is being demanded by firm, because firm needs labor as input to produce output. Who supply labor? Supply of labor are household. The moment they work in the factory or in any production site, then they are supplying labor in terms of hours. Okay, so next things, so remember, yeah, firm demands labor. We need to have some assumptions here. Number one is that product market is a competitive market. Now, firm demand labor to produce output. Output here, like I said, is a product. Product here sold in the market, and that market is a competitive market. In competitive market, we have demand and supply for competitive market, and the price here determined by the market forces. Because the supply is determined by market forces, therefore firms here in the competitive market take the price as it is. Remember price taker? Okay, so firms here is a price taker. So whatever price of labor or wage rate of labor determined by the market based on the demand and supply of labor forces, then the firm here will take it as it is. Okay, because the firm is not a monopoly in terms of buying labor. You get what I mean here? All right. Sorry, in terms of us, it's not a monopoly in terms of selling product. I'm not talking about labor. I'm talking about product. So let's say that product is shoes. This firm will use labor to produce shoes. The shoes that this firm is selling is in a competitive market. In a competitive market, the price of shoes, which is P star here, is determined by the market forces or demand and supply equilibrium. Therefore, the firm takes the price of shoe as it is. So firms is a price taker in selling the shoes, because in the competitive market, if you recall back your microeconomic study, we have many buyers, we have many sellers. So many buyers, many sellers here creates demand and supply forces. So you go through the bargaining process and whatnot, and then you cannot dictate the price alone, because you are price taker. You don't have power to control over the price because you are not the only seller in the market. Okay, now in order for this firm, I'm just making up the story. For shoes, actually, it's not a good example of competitive market input, but I just want to make it easy to understand. Okay, now for firm to produce shoes, firm needs labor and of course raw materials. But here we want to discuss about demand for labor. So firm needs input, that is labor. So firm needs to go to the input market, and in input market also, and firm is the demand. Firm is not the only firm that demand. This firm is not the only firm that demands labor. There are many other firms that also demand the same labor for their own production, regardless whether they produce shoes or whatnot. You get what I mean here? So in this case, we have demand and supply for labor as well, and it is competitive. So the price of labor, which is wage rate, is determined by the market forces. Okay, is it clear? All right. Now, let me erase the mess. So to produce output, like I said earlier, every firm or each firm needs to have raw materials and labor. So labor will combine all of the raw materials and also fixed input there to produce output. And all of the inputs, labor here, firms need to pay. Okay, so it involves cost. So what kind of costs involved in the production process? So this is again a revision so that you are not, going astray from what we are discussing in terms of demand for labor. Like in your undergraduate studies, we have two different types of costs, fixed costs and also variable costs. Now, fixed costs are cost of machines used in production, buildings used and whatnot. Once you pay for this cost, the machine is still there even if you don't want to produce any product anymore or any shoes anymore. Why? Because you have paid it, and it becomes a sunk cost, the cost that cannot be recovered even if you don't produce anything. Now, what about variable cost? In this case, variable cost is the cost of labor use. If you want to include raw material cost, you can also include, but at the macro level, we prefer to talk about labor first. Yeah. So we normalize this cost in the following equations. Yeah. If you have fixed and variable cost, then you total up, then it becomes total cost, which is this. Okay, expression 2. Total cost consists of total fixed cost plus total variable cost. Now, total variable cost here varies, depends on the number of labor you hire, the number of labor hours you hire. And the total cost here becomes wage rate times the number of labor hours, so that it becomes total wage, isn't it? Now, the total wage here is actually the total variable cost. If you look at the letter that I'm using here, it is capital W, then we are referring to nominal wage. Okay, nominal wage. Now, once we have this, we want to differentiate equation 2 with respect to labor hours, which is capital N. Okay, so here is very simple. You differentiate total cost with respect to N. You can see N appears here. So you just apply a simple differentiation rule. Then you have differentiate N, it becomes 1 times W, isn't it? So it becomes W. Okay, so what does it say here? This differentiation of total cost with respect to N says that if one additional labor hour has been added into the production process, then the additional cost will be equivalent to wage rate. So this is actually marginal factor cost or marginal cost. Okay, marginal factor cost. All right. Now, once we are done with that, if this one is nominal wage, right? We need to derive, remember our objective here is to derive demand for labor, and then after that we talk about supply of labor, combine both of them, and then we get market for labor. So in this case, what is W? W is nominal wage. Okay, if we want it to be real wage, it's very simple. Capital W divided by price level, you get real wage. So this one is real wage per hour. Okay, what I mean here. So this is the price of labor in the nominal term. This is the price of labor in the real term. Now, if you look here, let me do something. Remember, for every firm, their objective in involving themselves, for every entrepreneur, their objective in involving themselves in production function in any business is to maximize profit so that they can earn more income. All right. So remember, everyone wants to maximize profit. Okay, and you know that profit is basically total revenue minus total cost. And you know that total revenue is actually price times output, isn't it? Price times quantity, price times output. And total cost is basically total fixed cost plus total variable cost. If I specify it further, it becomes P times Y minus total fixed cost minus capital WN. You see what I mean? Okay. Now, we also know that Y is given by this function. Y is a function of labor and also fixed capital. So I can also rewrite it here as a function of labor and also fixed capital. Therefore, I can rewrite it here price times Y specifically as a function of labor and also fixed capital minus total fixed cost minus WN times N. Can you see? So this is the profit equation, and this in the slide is referring to expression 4. Alright, so remember again, we want to derive demand for labor, and demand for labor comes from firm. Okay, comes from firm. And every firm, when they hire labor, they need to make sure that this labor can produce output. They sell it in the market to maximize profit. So this is the profit function. Now the next question is, how do they demand labor in such a way that they can maximize profit? Okay, to do this, we need to do mathematical derivation. From profit function, we try to maximize profit. So that means, mathematically speaking, we want to get the first order condition of profit function. That is, we take the profit partial derivative of profit with respect to labor, and equate it to 0, and this one is actually marginal, marginal profit, and marginal profit equal to 0. If you have profit function, when marginal profit equal to 0, this is profit, this is labor. The slope of profit is 0. Okay, marginal is the slope of total profit. Okay, so that's why we do it this way. Equate it to 0. That means we are trying to find FOC. Basic maths, eh? From here we can find, the price, the wage of labor that can maximize profit. So how do we do it? Okay, let me rewrite it again here. Profit is given by P times Y as a function of N fixed capital minus total fixed cost minus W times N, total variable cost. What we need to do is find first order condition of profit function, that is differentiating profit with respect to N. Okay, now you look here, how to do it. We have two parts here, this part and this part that consists of N. This part doesn't consist of N, therefore this part is like constant. It's like 5. If 5, you differentiate with respect to N, what do you get? 0, isn't it? Okay, now, how to differentiate this with respect to N? You look at price. Price doesn't depend on N. Price is therefore a constant. And price is also constant for this firm because remember, firm is a price taker. So price is given in the market. So price is constant. So price behaves like 5. But N consists in output production function. So it's like X. So when you differentiate, you have 5. You get what I mean here? Something like that. Okay, if you have 5x. But if you have this, how do you differentiate it? Okay, P is constant, leave it there. Multiply by what? Multiply by the derivative of y with respect to N. Partially differentiate y with respect to N. That's it. Can you go further for this? Cannot, because you don't know the exact function. What you know is that y as a function of N. Is it clear? So we are done with this. Minus what? Like I said, total fixed cost, it doesn't have N. So when you differentiate, it becomes 0. Minus W times N. You differentiate N here, it becomes 1. W is a constant. Don't forget, if it is FOC, first order condition, the marginal profit here must be equate to 0. Why we must equate to 0? Let me erase the... Because we are talking about profit maximizing condition of firm. Get what I mean? Now once we equate it to 0, what we can do? Rearrange. Let's call this one, let me check. This is 4. So this is 4. Let's call this one 4A. Rearrange 4A. You get P delta Y over delta N equals to W, isn't it? Alright, now if you recall back this bit, how do you explain it? It is a change in labor. 1 unit change in labor leads to 1 unit change in labor leads to increase in output. Therefore, this is marginal product of labor. If you add 1 extra unit of labor, output will change by how much? You get what I mean here? So this is marginal product of labor. Then I've substituted here. So this one I call it 4B. Okay, substitute delta Y over delta N equals to MPN into 4B. What do we get? Then we get P times MPN equals to W, capital, yeah, sorry. So this is actually nominal wage. Nominal wage is price times marginal product of labor. If I want to have real wage, it's very simple. Capital W divided by P equals to MPN. Okay? Or W small letter MPN. Such that W is actually capital W over P. So from here, we have derived demand for labor in the form of Marx expression. Okay? Right. Now, the demand for labor shows what? The wage rate must always be equivalent to marginal product of labor. Right. So here I put it in the form of graph. So if we want to put it in the form of real wage, W over P equals to small letter W. This one is number of labor. The demand for labor is actually downsloping. Okay, this is demand for labor equals to MPN. So at this point, let's call it W naught equals to WOPO at point A, and naught at A, WO over PO capital, yeah, equals to W naught small letter equals to MPN naught. If you have B, then you have W1 equals to MP N1 at N1 at B with N1 demand. Okay, with N1 demand. Now, so here, if you look at the demand curve here, it is downsloping. How do we know that it is downsloping? Simple. Demand for labor, no firm will hire more labor if price of labor decreases. As simple as that, isn't it? Okay, as simple as that. All right. Now, let's say this MPN here, I call it FN. So I can also rewrite it this way. Real wage is equivalent to Fn equals to MPN. Okay, so this is demand for labor. Alright? Okay, now we are done with the demand for labor. But before that, can you explain to me what happens? You have to find this yourself. Where if in the Q&A, if you ask this to me, I wouldn't give you answer because this is your own homework. Yeah? What happens if we are at C? At C, can you compare between wage rate and also MPN? Are they equal? Are they less? Yes. So this is the question. At C. And if they are not equal, what happens next? What adjustment should be done for the demand for labor here? Let's say here Z. What happens? Is it like this? Check it. Because this is just revision, yeah, from what you have learned in your intermediate, in your undergraduate level. When we are done with the individual demand or individual firms' demand for labor, now we want to move to the second part of the labor market, which is supply for labor. Now remember, like I said earlier, when we talk about the supply of labor is actually comes from household, right? So remember, supply of labor comes from household. Like me, I'm working, I'm supplying my labor effort here in terms of hours. So it comes from household. Demand comes from firm. Remember this because always students get confused between these two because they think that supply is firm, demand is labor. You get what I mean? Because they think about, instead of thinking about input, they think about Apple, they think about products, they think about shoes. So don't be confused. Now, so first, in order for us to derive supply of labor here at the aggregate term. Now, before I forget, when we talk about the demand for labor, otherwise I forgot here. The aggregate demand for labor also looks like this, okay? And this is capital N here, okay? Now, anyway, let's go back to this. So when we talk about the supply of labor here, we want to look at the individual household first. And then once we have the individual household behavior of supply of labor, we combine all of them to get the aggregate supply of labor in the market. Okay, so there must be some assumptions again. So what are the assumptions? You imagine each person or each household has 24 hours from 0 up to 24 total time. Let's call this total time T, capital T. And then this total time here can be divided into two, work and also leisure. Let's denote leisure as capital S. When you work, you earn income. Okay, you earn income. Now, so if you work, you expect income. So let's call this expected income. If you go for leisure, your trade-off is expected income. If you go for work, your trade-off of income is leisure. You get what I mean here? Expected. Your trade-off of your expected income is your leisure, because you only have 24 hours per day. All right. So that means if leisure is S, total time minus S is actually working hours, isn't it? You get what I mean here? So if this one increase, this one has to decrease because we have fixed 24 hours per day, or that is fixed T. Okay, because this is equal to 24. You get what I mean here? Now, either you work or you leisure, both of them will give you utility or happiness. So utility is a function of expected income and also leisure. The higher the expected income, the higher the utility. That's why you have positive relationship between expected income and your utility. What about leisure? The higher the amount of hours you spend for leisure, the more you are happier. The happier you are. So it's also positive. You get what I mean? Yeah, so this one is positive. Normal human being. You get what I mean? Okay? So that's the basic idea about each household, individual household. Now, what do we need to do next? Remember, we want to derive the supply of labor. Because we want to derive the supply of labor, now, we need to know that you can supply labor hours, you can earn income, but you have limitation in terms of budget constraint. So how does the constraint look like in terms of mathematical expression? Look here. So this is the individual constraint represented in expression 7 or equation 7. As you can see, expected income you receive is actually equivalent to the real wage, expected real wage, times the labor hours, which is the total time T minus S leisure hour. And then total time T minus S, like I said, working hours for the individual called N, small letter n. Okay, right now we use expected price here instead of actual price. Why? Because we have expected income here. Again, usually expected incomes being, fluctuated because of the price. Okay, you expect what happens to the price later and whatnot. Okay, so this is the constraint or the budget constraint for individual household. And can you find on your own what's the slope of 7? Now, basic idea is we call back the utility function that you learned in intermediate micro 1 for undergraduate level. Okay, you have good A, good B, and then you have budget constraint. In this case, A is expected income, B is the total time you spend for leisure and also working, and then you have utility function to satisfy your wants. Right? So that's the idea. Now, we want to decide if a person wants to decide how many hours could he spend for working, which is small letter n, and also leisure, so that both of these activity could maximize his utility. Then he has to go through the utility maximizing process. Now I'm going to show you in the form of graph, utility maximizing process. So let's say we use this graph. Remember, we want to decide the number of working hours and also leisure hours and also income here in the form of graph that could maximize this person utility. And you know that utility is a function of leisure and also expected income, isn't it? That's what we understand. Okay, for this frame of diagram, we have total income, a total time here. Okay, as you move to the right, then you spend more leisure. As you move to the left, then you spend less leisure, means more hours of working. Now what is it on the vertical axis? Your expected income. Okay, now let's say initially you are having initial situation. Okay, let's say your real, which is at W naught, which is equivalent to W over P naught R, right? And then, so in this case, if you don't work, you spend all of time for your leisure, then you are here, you don't receive any income. But if you work, you don't spend your time at all for your leisure, that means you are here, isn't it? You can receive maximum income, let's say here. Okay, and what's the maximum income here? I call it YE prime equivalence to your current real wage, okay, times time spent for working minus leisure. Now because time spent for working minus leisure here is 0, isn't it? Therefore it's just wage rate in real terms multiplied by total time. Okay, then you join the 2 points, you get what we call budget line. Okay, now let's say this individual household spend, this is 0 time, spend his leisure at this particular S0 from here to here. So working is only this much, okay, and not. And therefore, the income received is here. Let's say YE naught. YE naught is equivalent to real wage W naught times time, total time, minus leisure hour, which is S naught. Okay, is it clear? All right. And then here he is happy because we know that utility function looks like this, W naught. Okay. At point A, capital A here, budget line is a tangent to the utility function U naught. Therefore, this person has maximized his own utility by spending time for leisure equivalent to S naught, spending time for working equivalent to this, which is N naught, receiving expected income, which is W naught times T minus S naught. Okay, so this is initial situation. Okay, now from here, let's say we have new thing happens. Let's say wage rate increases from W naught to W1. So here 1, okay, such that W1 is greater than W naught in real term, yeah. So what do you expect? What will happen here? At this moment, if he doesn't work, even if income increases, then he's still here. But if he works, he may receive higher than YE prime, isn't it? If he works all of the time. So if he works all of the time, then he may receive it somewhere here. For instance, I call it YE double prime, which is W1 times T all. I join the 2 points, then I get the new budget line. That's how it is affected, yeah, when the real wage increases, budget line will fan outward. Fan outward on the vertical axis, not on the horizontal axis. So then, that means the current utility function, which is U not here, this one, is no longer the utility function that can satisfy his happiness, that can maximize his utility satisfaction. Why? Because it's obviously U naught is intersecting with the new budget line here at this point. If you want to say that it has maximized, it has to be, the new budget line has to be a tangent to the utility function. That means the new budget line here has to be tangent to another new utility function, which is not U naught, because U naught is intersecting. So go back to the principle, yeah, principle of micro and whatnot. Why, if it is intersecting, it's not called maximizing utility and whatnot. Okay, so what does it mean? We need to find a new utility function that is a tangent to the new budget line here. Logically speaking, when wage rate increases, would you spend more hours for working instead of leisuring? Yes. So you would decrease your, leisure time. You increase your working time, isn't it? What should we do here? So S naught decreases to, let's say, S1. Decreases means move here. Let's say S1 is here. So when S naught increases to S1, that means T minus S1 should be bigger than T minus S naught, isn't it? This is working hours. So let's say it's here. Okay. That means the income received is also higher. What happens to income? W1 times T minus S1. Call it YE1 is here. Equilibrium income W1 times T minus S1 equals to YE1. Hold this point B. Therefore, point B, there must be utility function that is, that has budget, this new budget line as a tangent to the utility function. So let's say this one, U1. So this leads to at B at U1. New budget line is a tangent to U1 at point B. Okay, as you can see here, when wage rate increases, you can see leisure hour reduce, working hour increases because expected income is increasing. Let me put E here. I forgot to put E here. I should put E, otherwise it's wrong. Right. So because of that, you can see clearly substitution effect happens. The individual household is substituting his, his time, spending more time for working when he knows the increase in wage rate could give him higher income later. Okay, he's motivated to work more, spend less hour of leisure. You know what I mean here? But at the same time, sometimes some people you can see when there is an increase in income or wage rate, they spend, they reduce their working hours because they believe that by working lesser, they can still get the same amount of income as before, because now wage rate increase has compensated the loss in reduction of hours working. You get what I mean here? That is income effect. But in this case, moving from point A to point B for this individual household is that the hours spent on leisure has reduced, and therefore the substitution effect dominates the income effect. Now you might be wondering, how do we know that there is a substitution effect and income effect? How do we visualize this in this diagram? Of course we can visualize it in this diagram, but the whole thing here is a revision, yeah? I'll tell you. What? Revision of microeconomics during undergraduate. Check the YouTube on the work-leisure decision that are talking about all the videos related to the work-leisure decision to figure out from many videos. First, how to analyze the substitution and also income effect for the work-leisure decision in detail. Then you can see those graph, the explanation and whatnot. And those have been learned in microeconomics during undergraduate level, yeah? So that's why I don't explain it here, but I may ask you in the assignments and also quizzes and also, project paper and whatnot. Okay, now, in this case, it is very obvious that substitution effect is more than the income effect. Try to figure out what happens if income effect dominates the substitution effect. Okay, now put that aside, do it at your own time, but you have to do it right after I request you to do it in this video. Graph actually can be used to derive individual labor supply. Okay, now how do we derive it? If you look here, the first frame of diagram here refers to this graph here. This one should be put here. Okay, now I want to put it in the second graph, so I erase this one. Wait a minute. So here, from the first graph here, we know that we have initial wage rate, W naught, and then we have T minus S naught equals to N naught. Yeah? This is time for working labor hours. Okay, and then wage rate increases to W1, then the time working becomes this. W1 more than W naught, N1 more than N naught. Is it clear? So we have N here, labor hours. We have real wage rate here. So the first one is N naught with W naught, which is here. The second one is N1 and W1, which is here. So we have point A prime, point B prime. Point A prime correspond to point A in the first graph. Point B prime correspond to point B in the first graph. Join the 2 points, you get labor supply. Now for this labor supply here, I call it GNI, labor supply of individual I. Okay, so this is NI, labor hours of individual I. Individual I, individual name Ali, individual names Ahmad, you get what I mean? And then don't forget, this is suspected wage. Okay, this is suspected wage. Alright, now if you want to have it in the form of aggregate labor supply, how does it look like? This is each individual. If you have all, then you sum of NI equal to N1 plus N2 plus N3 until N, the last N. Then you get total capital N, or labor in the market. Yeah? So here, aggregate level supply. Let me erase this one because I forgot to delete this. Okay, if you want it to be in the form of real wage, then we have a small letter W and then N here. Okay, and then we have this G capital N instead. Okay, but remember, real wage consists of nominal wage divided by price. So if I want here to be nominal wage, then it means cross multiply, isn't it? So remember, this one equals to GN, then it becomes nominal wage equals to price times G capital N. You get what I mean? So here you can have price times G capital N. Oh, I forget, yeah, this is this, because we are talking about expected wage, expected income. So we have N here. That's how it works. Now N here, don't forget, this is the sum of NI, the sum of NI. Alright, now what we are dealing with here is expected wage and expected income. Now, is it possible to change expected wage to real wage? Yeah? Let's look at the mathematical derivation. We have expected real wage. We want to change it to actual real wage. We know that expected real wage is actually nominal wage divided by expected price, and then this is actually equivalent to this, remember? Okay, you see this one? This is actually equivalent to this. Okay, now let's call this one A. So if I rearrange it, then I can have something like this. So I have nominal wage, cross multiply the expected price, I have PE GN. So I call this B. Okay, so let's write a ratio of something like this. Actual real wage over expected real wage is actually this over this, isn't it? So mathematically, you can simplify it. It's equivalent to 1 over P over 1 over PE, isn't it? Yeah, because this one and this one cancel out each other mathematically. So this can be rewritten as actual real wage equivalent to PE over P equals to, sorry, not equals to, multiply expected real wage. Okay, so this is how we try the real wage is actually equivalent to this one C. So we are done with the supply of labor at individual level and also the aggregate level. We have demand and supply. We combine both of them to get what we call labor market, and then we can determine equilibrium in the labor market to determine the equilibrium wage rate and also equilibrium employment. Alright, so let's look at the equilibrium labor market. So equilibrium labor market is a condition where we have this. If you look here, this is labor demand, this is labor supply, aggregate labor demand, aggregate labor supply, this is nominal wage, or the form of real term. What you do with expression 8 is divide both sides of 8 by 1 over, sorry, by P, not 1 over P, by P. So when you divide it, let me show you. Divide by P, divide by P, divide by P. What you get here is that W over P you get real wage. P cancel, you are left with Fn. This you have this and this. So this one is labor demand. This one is labor supply in real term in equilibrium position. This is equilibrium position in nominal term. This is equilibrium position in the real term. Now let's try to put it in the form of graph. So in the form of graph, here, let's say we have real wage, employment. So we have Fn, the labor demand, and this is actually equal to MPN, remember? And then this is labor supply, expected price over actual price, GN. Okay. Then we can have W naught and naught. What about if we put it in the form of nominal? Nominal wage, labor hours. So we have labor demand, remember, which is shown by this, remember, this bit. Okay, and then we have labor supply, which is this. So we have here W naught and naught. So this is A prime. Okay, so equilibrium real, which is this, equilibrium nominal, which is this, equilibrium employment,